Hi everybody, in this video we're going to go over test number 5 on quadrilaterals. So in the first question it tells us that we have a regular pentagon, and the word regular means that all of the sides and the angles are congruent. We have a formula for finding the sum of all the interior angles of any polygon, and that is the formula n minus 2 times 180 degrees. Now n is the number of sides or angles that the shape has, and since this is a pentagon, there are 5 sides and angles. So n would be 5 here. So we have 5 minus 2 times 180. That is 3 times 180, which is 540 degrees. So 540 degrees is the sum of sum of all of the interior angles in the pentagon. So to find each one, we just need to divide by the number of angles that there are, since all of the angles and the sides have the same measurement. So we have 540 divided by 5, and that gives us 108 for each angle. That means this angle is 108, this whole angle here is 108, this whole angle is 108, this angle is 108, and so is this one. All 5 interior angles are 108. But we are looking for angle AEB, so that's just this piece of this angle over here. Since this is a regular pentagon, not only are all the angles the same, but all of the sides are congruent as well. So this triangle at the top here is actually an isosceles triangle, and that means that the 2 base angles are congruent. So if the top angle is 108, then these 2 angles need to make 180, since all of the angles in a triangle add to 180. 180 minus 108 is 72 degrees. And since each of these angles needs to be the same, let me divide that by 2. And that gives me 36 degrees for each of these angles. Let me double check. Once again, all 3 of these angles should make 180 degrees, since all 3 angles of any triangle add to 180. So if I add 108, 36, and 36, I should get 180 degrees. So that is answer choice number 1. For number 2, it is talking about the exterior angle of a polygon. And we know that no matter what polygon we're talking about, all of the exterior angles of any polygon, regardless of how many sides it has, the exterior angles always add to the same number, to 360 degrees. So if this regular polygon, that means all the angles are the same. If this regular polygon has an exterior angle that measures 60, and I know that all the exterior angles add to 360. If I do 360 divided by 60, that should tell me how many exterior angles that there are, which is how many angles and sides the shape has. So that would be 6. So that tells me we're talking about a 6-sided shape, which is actually a hexagon. And to verify, if you do 60 times 6, that should give you 360. Okay. For number 3, so we're told that E and F are midpoints of the sides of the triangles that they're on. And, we're told that triangle ABC is equilateral. So I know these 2 sides and this side are all congruent because it's an equilateral triangle. Since E and F are the midpoints of the sides that they're on, we can call segment EF the midsegment of triangle ABC. And we know that the midsegment is half the length of the side that it's not touching. So if the midsegment is represented as 2x plus 8, and AB is represented as 7x minus 2, I can make an equation that says this doubled gives me this, or half of this gives me this. I'm going to go with the first option. If I double the midsegment, I'll get the third side of the triangle. So if I take 2 times the midsegment, I get the side that it's not touching. Quickly solving, that's 4x plus 16 is equal to 7x minus 2. Subtracting 4x from both sides, adding 2 to both sides, that is 18 is equal to 3x. And then dividing by 3, we have x is equal to 6. So we are looking for the perimeter of A, B, F, E. So I need all the side lanes. So now that I have x is 6, I can plug in and I can find EF and I can find AB. So let me plug in to find EF. So that's 2 times 6 plus 8, and that's 20. So we just found that this is 20 EF. And we know that AB should be double that, but I can plug in just to verify that it is. 7 times 6 minus 2, and that is 40, exactly what we expect it to be, since the side that the midsegment is not touching should be double what the midsegment is. Now we know two sides of this trapezoid, and guess what? We knew triangle ABC was equilateral. That was told to us in the question. So if we know that one side of the triangle is 40, that means all the sides of the triangle also have to be 40. And guess what? E and F were midpoints of the sides that they're on. So if the whole thing is 40, each half is 20. If the whole thing is 40, each half is 20. So now we have all the sides of the trapezoid at the bottom. We have the 20 and the 40. We have this 20 and we have this 20. We just need to add the four sides of this trapezoid together. 20 plus 20 plus 20 plus 40. That's 60 plus 40. That is 100. Okay, for number 4, we need to pick which choice is not enough to prove that we have a parallelogram. So we're looking for the answer choice that does not prove a method of proving that you have a parallelogram, one that does not work, an invalid method, basically. So let's take a look at number 1. AB is congruent to CD, and AB is parallel to CD. This works. We do have a theorem that says if one pair of opposite sides is both congruent and parallel, then the quadrilateral is a parallelogram. So that is a valid method. I'm going to reset, and I'm going to try answer choice 2. AB is congruent to CD, and BC is congruent to AD. This is a valid method. We know that if both pairs of opposite sides are congruent, the quadrilateral is a parallelogram. So I'm going to reset there, and I'm going to try answer choice 3. AB is congruent to CD, and BC is parallel to AD. Well, both pairs of sides are incongruent. Both pairs of opposite sides aren't parallel. And we don't have one pair of opposite sides that is both congruent and parallel. So this is not a valid method. So this is actually the answer choice that we're looking for. And if you wanted to try out number 4, from the information in number 4, you'll see that it shows that both pairs of opposite sides are parallel, which is valid. So that's why answer choice number 4 is not the right choice. That is a valid method, that both pairs of opposite sides are parallel. Okay, moving along. So here we have a rectangle, and in a rectangle, we know that a special property is that the diagonals are congruent to each other. That means they're the same as each other. So if RT is 6x plus 4, now keep in mind RT is the whole diagonal. And SO is 7x minus 6. Oh no, SO is not the whole other diagonal. It is 1/2 of the diagonal. So to get the whole diagonal, we are going to need to double this. So let me set up my equation. If I double the half of the diagonal that I'm given, that'll give me the whole diagonal. And this whole diagonal should be equal to the other diagonal, because we know that in a rectangle, the diagonals are congruent to each other. Really quickly solving, let's distribute that 2. That's 14x minus 12 is equal to 6x plus 4. Let me subtract 6x and add 12. So that is 16. And that is 8x. Divide by 8, we have 2. So x is equal to 2, and it's asking for the length of the whole diagonal US. I know that US and RT should be the same since diagonals are congruent. So you can either plug into the 7x minus 6 and multiply it by 2, or you can just plug into RT because that's already the whole diagonal. Let me do that right now. I'll just plug into SO. So I'm going to do 7 times 2 minus 6, and that's 8. And now I need to double that to get the whole diagonal, and that's 16. So the length of the diagonal is 16. Okay, here we have a rhombus. Now, what a lot of people were doing is thinking that in a rhombus, the diagonals are congruent. That is not true. That is a property of a rectangle. Rhombuses have separate properties from rectangles. So the diagonals are not congruent in a rhombus. You cannot assume that from just knowing that you have a rhombus. So if you wrote that on your paper, that's why you got most of the points off. That is not a property of a rhombus. That's a property of a rectangle. So they tell us that AD is 10. So they're already giving us one side of the rhombus. And keep in mind, if one side of the rhombus is 10, that means all the sides of the rhombus are 10 because a rhombus is equilateral. That might be important later. We'll hold on to that. They're telling us that the length of diagonal AC is 12. And since rhombuses have all the properties of parallelograms, I know that the diagonals bisect each other. So if this whole diagonal is 12, I know that each half is 6. And we need to look for the length of the other whole diagonal. So we're looking for DB. And once again, since rhombuses do have parallelogram properties, I know that this diagonal is also being bisected. So if I can find what half of the diagonal is, then I can find the whole diagonal by taking what the half is and just multiplying it by 2. So I'm also going to keep in mind my other properties of the diagonals of rhombuses, since I do have a rhombus here and they do give me the diagonals. I know that diagonals bisect the angles, but I don't have any angle measurements to work with, so that's not going to be super helpful to me here. I do also know that the diagonals are perpendicular to each other. That means that where they intersect, 90-degree angles are formed. And now that might be super useful to me because now what I have are right triangles. And I have 2 sides of the right triangle already. I'm looking for the last side. And I know that when I have 2 sides of a right triangle and I want to find the missing side, I can use the Pythagorean theorem to do that. A squared plus B squared equals to C squared. Now, keep in mind, C has to be the hypotenuse. A and B are the legs. It doesn't matter the order, but C has to be the hypotenuse. And the hypotenuse is located across from the 90-degree angle. So we already have the hypotenuse here. It is 10. So I do need to plug that 10 in for C. Now, A could be 6. That's the other side that we know. And I can leave the unknown side as B because I'm solving for it. But that 10 does need to go in for C, else you will not get the right answer. You're not looking for the hypotenuse here. You have it. Okay, so we have 36 plus B squared is equal to 100. Now we just need to do 100 minus 36. And that is 64. So B squared is equal to 64. Taking the square root of both sides, we have B is equal to 8. Now remember that that represents this side of the right triangle, so that's half of the diagonal. So the other half would also be 8, making the whole diagonal 16. So the whole diagonal DB would be 16. Okay, so I'm actually going to solve the whole question 7, even though depending on what class period you were in, you might have only been required to do part of 7A and not do 7C, but other class periods might have been required to do different ones. So I'm just going to solve the whole thing here, so that way you can see how to do it. So I'm just going to pause the video so I can graph the quadrilateral. Now, especially for part 7B, for the area question, it is very important that you accurately graph the quadrilateral. Also, it's going to be very, very hard to calculate the area later on. So for 7A, there's many different ways that you can prove that you have a parallelogram. So I'm just going to go with the distance formula. So what I'm going to do is I'm going to find the length of AB, the length of DC, the length of AD, and the length of BC. Since AB and DC are straight horizontal lines, I can just count the boxes to find their length. So I'm going to do that. And when I count the boxes from D to C, I get 11. And from A to B, I also count 11 boxes. Now, AD and BC are slanted lines, so I'm actually going to have to do the distance formula. So I'm going to just pause the video so I can plug into the distance formula and see what I get. Okay, so here I have all of my work and my calculations for proving that we have a parallelogram. Notice that I have my distance formulas, and then I have a concluding statement explaining what my calculations show. So since I use distance formula, I was showing that both pairs of opposite sides are congruent, And that's what made ABCD a parallelogram, the fact that both pairs of opposite sides are congruent. Now, keep in mind that's not the only way you could have proven it was a parallelogram. You also could have used slope formula for all the sides, and that would be showing that both pairs of opposite sides are parallel. You could have taken one pair of opposite sides, like AB and DC, and found the length and the slope to show that you have one pair of opposite sides that is both congruent and parallel. That would work. And finally, the last way is you could have drawn in diagonals DB and AC, and you could have found the midpoint of diagonal AC and diagonal DB. And if the midpoints are the same, which they will end up being, you'll know that you have a parallelogram because the diagonals bisect each other. If they have the same midpoint, that means that they cut each other in half. So the diagonals bisect each other, which proves you have a parallelogram. Any of those ways would have worked, but your concluding statement does need to explain which property you did show with your calculation. So make sure your concluding statement shows it. Now, to show that you don't have a rhombus, since I used distance formula, my calculations already show that. I just need to add another concluding statement, which to save some space, I'm not going to write down in the video, but I will say it out loud. I can say, since ABCD is not equilateral, it is not a rhombus. Remember, in order to be a rhombus, your parallelogram needs to be equilateral or have congruent consecutive sides. As we can see here from my lengths, any two sides next to each other have different lengths. 11 and radical 85, 11, radical 85, radical 85, 11. So any two sides next to each other are not the same. So either way would have worked to explain it. Parallelogram ABCD is not a rhombus because it's not equilateral, or because it doesn't have congruent consecutive sides. It means the same thing. Now, showing it's not a rectangle. To show it's not a rectangle, if it was a rectangle, if I take two sides and I find the slope, they'll have opposite reciprocal slopes, which means that they'll form a right angle. But since we're proving it's not a rectangle, if I take the slope of AB and AD, they won't have opposite reciprocal slopes. The slope of this horizontal line will be 0, and the slope of AD, which is like a slanted line, will be something completely different. So they won't be opposite reciprocal slopes. So if you find the slope of two sides next to each other and you see that, they're not opposite reciprocals of each other, then you can just write your concluding statement. Parallelogram ABCD is not a rectangle because since the sides don't have opposite reciprocal slopes, there's no right angles. Remember, in order to be a rectangle, it should have a right angle. Or, second way, you can find the length of AC and BD, the diagonals, with distance formula, and show that the diagonals are not congruent. Because remember, if it was a rectangle, it would have congruent diagonals. So that's a second way that you can show it's not a rectangle. Now for part B, in order to find the area of the quadrilateral, the best way to find the area of any polygon on the coordinate grid is to draw a box around the shape and make sure to include all the vertex points in the box. So from A to B, there's a straight line already, but let me just make my box. Oops, I want this to be super straight. So let me try that again, because if my box is inaccurate, it's going to be really hard for me to figure out the area. So let me start at A, and I'm also going to want to include vertex point C. Oops, I will get this. It's super, super hard on the computer. So I'm going to go to where point C is. Point C is at -3, -1, negative. I want to just make sure I get this accurately. 8, 1, 2, 3, 4, 5, 6, 7, 8. There we go. Okay. Perfect. Now I'm going to make my box come down to vertex point C. Because remember, I want to completely enclose all of the vertex points in my box. And then I want my next part of my box to go from C to A. So let me come here and let me go to point A. And then my last one will be up to point A. There we go. So that's pretty accurate, that box over here. And as you can notice, there are two right triangles that are formed when I made the box. So what we can do is we could find the area of the whole entire box, that's length times width, and we can subtract off the two right triangles. And once we do that, we'll be left over with the area of the quadrilateral ABCD that we're interested in. I'm going to call this triangle 1 and this triangle 2 so that we know what we're referring to. First, I'm going to count the boxes for the length and the width of the entire box. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So from A to the end of the box, that is 13 units. And let me count down 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me just double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 units. So in order to find the area of the whole box, I'm going to multiply the length times the width. So that is 13 times 9. And I get 117 for the whole. So let me make a spot for me. And my whole is 117, my length times width of the entire box. Now I'm going to find the area of triangle 1 and the area of triangle 2. So let me do this like off to the side over here. So triangle 1 is 1/2 base times height. With triangles, it's really easy to find the base and the height because they're the two legs of the right triangle. So counting the base, that is 2 units, and the height, 1, 2, 3, 4, 5, 6. 6 units. So my bad, I miscounted there. That is not 6. Let's count that one more time. So hard to count this on the computer. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9 units for the height of this right triangle. So what we have here is half of 9 times 2. 9 times 2 is 18. So we have half of 18, which is 9. And if we take a look at triangle 2, we'll notice that the base is once again 2 units, and the height, this one's a little bit easier to count on the computer here. The height is 1, 2, 3, 4, 5, 6, 7, 8, 9. So same dimensions as the other triangle. So it's going to be half of 9 times 2, that's half of 18, which is also 9. So the area of triangle 2 is also 9. So what we have here is the whole minus the two triangles. 9 plus 9 is the area of the two triangles combined, which is 18. And 117 minus 18 is 99 units squared. So that is the area of quadrilateral ABCD. It is 99 units squared. To find the perimeter of quadrilateral ABCD for part C, all you need to do is add up the sides AB, BC, CD, and AD. Back in part A, when I was finding the side lengths of the quadrilateral, I found that 2 of the sides were 11, and I found that the other 2 sides were radical 85. So 11 plus 11, that's 22. And radical 85 plus radical 85 is 2 radical 85. And that's the perimeter. Okay, moving on to the proof.